Ciao e benvenuti. Per chi non mi conosce, io sono Maria Pina, uno dei community leader della community XStream Data Lab. Il nostro argomento principale sono i big data, la gestione di data, l'architettura, soluzioni e tecnologie. Questa è la community XStream Lab, che è un luogo sia fisico che digitale in base agli eventi degli ultimi mesi, in cui ci confrontiamo su tecnologie innovative e nuovi modelli di gestione dei dati, approfondiamo il paradigma del mondo dei big data e ci scambiamo esperienze su innovazione digitale. Infatti la parolina lab l'abbiamo aggiunta per questo, perché soprattutto con gli ultimi meetup il nostro cimento è quello di sperimentare e fare laboratorio su approcci innovativi di gestione del dato. Gli argomenti che abbiamo trattato passati a trattare sono tutti solo nati in questa nuvola di parole. L'intento però è chiaro: architettura, tecnologie e soluzioni sempre viste con l'ottica dell'open source. Questo è alla base, diciamo, della nostra community. Per quanto riguarda questo momento, mi è un grande dispiacere darvelo in virtuale, un grosso benvenuto ai nuovi iscritti. Noi non vediamo l'ora di poter riorganizzare degli appuntamenti fisici e questo spero già possa avvenire dopo l'estate. Manterremo sicuramente anche degli appuntamenti online, perché la community è distribuita in diverse città italiane e in questo momento abbiamo anche appunto degli ospiti da fuori confine, e questo, diciamo, comunque è una gran cosa. Quindi dopo l'estate cercheremo di organizzare sia degli appuntamenti in presenza che degli appuntamenti online, e sarete chiaramente avvisati tramite le nostre piattaforme che sono più avanti poi raccontate. Abbiamo due partner che ci sostengono in questo. Uno è 𝐶𝐽𝑚otion, siamo community di 𝐶𝐽𝑚otion e siamo presenti sulla loro piattaforma e invitati in molte delle loro iniziative, e siamo diciamo supportati da 𝐶ICOM, che è al nostro fianco dal 2014. 𝐶ICOM ha due anime, quella della smart collaboration e quella della gestione dei big data, e 𝐶ICOM è parte di RIOS, punto di riferimento in Italia per chiunque voglia sfruttare i benefici dell'open source, ma con la stabilità e il supporto di soluzioni enterprise. I fondatori di questa community in realtà nascono proprio da 𝐶ICOM e dagli incontri di networking che facevamo dal 2014, quando eravamo in trasferta e supporto dei vari clienti. Da questo è nato poi l'idea di allargare questo networking e di strutturarlo attraverso le varie piattaforme di community già da allora disponibili. Prossimo meetup, chiaramente adesso non abbiamo ancora dettagli, anche perché se ne parlerà dopo l'estate, ma siamo sempre aperti ad avere suggerimenti su idee sui contenuti da proporre, così come siamo aperti alle candidature come speaker. I nostri riferimenti a cui segnalarli sono la community su LinkedIn, sono la community su Telegram, il gruppo Meetup e il gruppo sulla piattaforma di 𝐶𝐽𝑚otion. Questi riferimenti li metteremo poi in chat, in modo che se non siete già iscritti potete magari aderire da subito e entrare anche sulle altre piattaforme. E a questo punto rivediamo l'agenda di oggi. Partiremo con un'introduzione che ci farà Stefano Pampaloni, altro community manager di questo gruppo. A lui si devono le idee innovative e l'evangelista, insomma, su futurologo, su quelli che sono i trend del big data management. E quindi a lui lascerò diciamo, l'onore o il piacere, soprattutto, ecco la parola giusta, il piacere di introdurre poi i due talk successivi, e abbiamo poi Ryan Murray con Project 𝗟𝐶𝐴, il GitHub-like Experience for Cloud Data Lake, l'agenda la conoscete, il secondo talk invece sarà quello di SODA, Monitoring and Testing Data Quality, e quindi avremo il Q&A finale. Su questo, come indicazioni, per agevolarci la raccolta e la gestione delle domande senza, diciamo, rubare poi troppo tempo, visto che si farà quasi l'ora di cena, scrivetele da subito durante il talk stesso, in modo che le organizziamo e le presentiamo poi agli speaker, e magari scrivetele anche già in inglese, così loro stessi possono leggere e organizzare magari anche delle risposte cumulative. A questo punto le start, appunto, interrompo la condivisione e invito Stefano a palesarsi e a prendere la parola.
Paleso, eccomi, mi vedete, mi sentite?
Sì, vediamo anche la presentazione.
Okay.
E ci dai un overview anche del meetup precedente, anche perché questo discorso nasce appunto dal meetup fatto un paio di mesi fa, che si chiamava Model Data Architetture 1, e di cui adesso continuiamo l'esplorazione in questo panorama introdotto nell'appuntamento precedente.
Sì, infatti, diciamo, la mia brevissima introduzione è proprio per riprendere un po' il filo del precedente meetup e dare un po' un senso a quello che stiamo facendo, quello che stiamo raccontando. Vabbè, chi sono io mi ha già un po' presentato Maria Pina, qui mi piace sempre rimettere questa foto perché era momenti in cui ci divertivamo ancora molto di più a fare i meetup, e speriamo di tornarci presto, insomma, a vederci dal vivo. L'altra volta avevamo parlato un po' di Modern Data Lake, di come oggi appunto sono strutturati i data lake e della necessità di avere un data lake engine per diciamo, essere efficienti nell'elaborazione dei dati, lasciandoli appunto in maniera abbastanza destrutturata su magari storage distribuito, storage a oggetti, e renderle fruibili queste informazioni a data scientist o a chi fa data analysis in maniera omogenea e con strumenti standard, quali per esempio driver o DVC o JDBC, o anche comunque metodologie d'accesso al dato più performante come Arrow, Arrowflight in particolare. Poi avevamo visto come in realtà, diciamo, la prospettiva di un data lake moderno deve andare verso la strutturazione del dato in maniera più importante, arricchendolo anche di funzionalità e di strutture più idonee ad essere analizzate e a garantire le adeguate performance. E quindi avevamo visto come uno stack, una pila di soluzioni, qui le vedete un po' alcune riportate, poi avevamo fatto degli excursus su quali potevano essere appunto le soluzioni open source per un data lake S3 compatibile, e poi avevamo presentato Dremio alla fine. E raccontato brevemente anche le necessità relative alla data governance, alla gestione della qualità del dato, alla gestione dei metadati collegati appunto al data lake. Oggi facciamo l'approfondimento su due soluzioni in particolare, ma ho preso questa immagine perché è il Data and Data e AI, intelligenza artificiale, Landscape del 2020, dove diciamo, fa veramente impressione la quantità di soluzioni, di strumenti, di prodotti che ci sono per appunto in ambito data lake. Se andate a rivedere come era fatto il landscape di 8 anni fa, first mark, mi sembra la prima volta l'avevo fatto 9 anni fa, nel 2012, praticamente era un decimo di quello. E questa è ridotta per farcela entrare, visualizzazione al 40%, se zoomiamo fino al 120 mi sembra, riusciamo a vedere quelli che erano evidenziati anche nella slide precedente, i due prodotti di cui parliamo oggi. In realtà oggi parliamo di Project NESSI, che è un'estensione, un progetto open source che è supportato da Dremio, e alcuni degli sviluppatori appunto che oggi ci racconteranno un po' di questo progetto sono dipendenti di Dremio. E poi Soda, che entra proprio nello specifico di quella che è la gestione della qualità del dato, che è appunto uno degli aspetti fondamentali della gestione dei data lake, perché è vero che il data lake dal punto di vista infrastrutturale ci permette di scalare e di diciamo, gestire in maniera anche economica, perché poi un grande successo che hanno avuto, ovviamente, oltre alla scalabilità, è anche all'economicità della gestione del dato, di grandi quantità di dati su questi data lake, ma come detto si portano dietro una carenza, no, di funzionalità, di controllo e di attendibilità del dato, che di fatto sta avvenendo a essere risolta con lo sviluppo appunto di nuove tecnologie specifiche per i data lake, che ci danno la possibilità di fare data governance, data quality e così via. Quindi oggi vedremo queste due soluzioni. Quindi io mi fermo qui, sono rimasto abbondantemente nei tempi, anzi forse ho risparmiato qualche minuto, per lasciare spazio ai nostri ospiti che ci racconteranno, ci parleranno di queste soluzioni. Tra l'altro ho sbirciato la presentazione di Project Nessi, ci racconterà anche proprio perché c'è bisogno di una soluzione di questo tipo.
And so let's start the English part of this presentation. I invite Ryan. Okay, I welcome you, Ryan, and thank you for joining us today in this meetup. I know that your mission is to simplify the data management. You work in Rinio, and you actively are a contributor to the open source community. Maybe most of your time is spent working with open source technology. Today you will introduce us to the project Nessi, one of the open source project that you are serving. The stage is yours.
Awesome. Thanks very much for the intro.
Please. Okay. Can you tell us something more about you if you want?
Yeah, I guess I've been at Dremio for about, it was actually 2 years today, funnily enough. And before that, I was working in the financial service industries. And before that, I was academia. So I've been working with data now for a good 15, 20 years. And I think what I'm sharing with you guys today, I think, is one of the coolest projects I've worked on since I've started in the industry. So yeah, looking forward to sharing with you guys. And thanks the organizers for having us. So yeah, let's get going. Let's just present the slides now. So the goal for today, first, I want to talk to you a little bit about the evolution of the data platform. So where it's gone over the past, 30 or 40 years. That'll lead us into a couple of the challenges in the current state, and obviously what the current state looks like. We'll then take a short break, and I want to jump into the Apache Iceberg and make sure everyone's kind of clear about what Apache Iceberg is and how it's being used in the data lake. And then I'll introduce you to Project Nessi, and then we'll talk about some of the use cases that Project Nessi can solve. And then we'll finish off with some questions. I actually won't have time for the demo today, but I'll share some links with the demo so you guys can try it out yourselves. So first, this is kind of a history of what our data platforms have looked like since databases existed. I'm not going to get too deep into this. What I really want to point out is over the past 10, 15, 20 years, we've really had two distinct types of technologies at play here, two paradigms, and that's the data warehouse and the data lake. And you can think of the data warehouse as, it's a database and it has all the things you want out of a database, the transactions and the managed storage and everything else. So when you have a data warehouse, you're going to have a batteries included type of tool with everything you could possibly want. But you're going to have a bit of, your vendor lock-in. It's typically a bit pricier, and you're going to need some specialist skills to be able to run that particular data warehouse. On the complete flip side, you have your data lake, and data lake is a bit of a wild west. There's no rules, there's no existing standards. It's just do whatever you want. The benefit there is you get to bring your own tools and you get to do your own thing, and you kind of you have a lot more freedom, but you pay for that freedom with a lot more work to make everything run smoothly. And that's kind of where we're at now. And then if we were to look at how these two things have been evolving in time, we can actually see that the data lake and the data warehouse have been going through this conversion over the past 5 or 10 years. And this is really saying what's the best of the data lake and what's the best of the data warehouse, and can we move those things together? So most notably our data lakes, which were in 2005 just random blobs of data, they've since picked up tables and a SQL interface, and you can now do transactions on tables through Iceberg and Delta Lake. And now we're looking at what's next for the data lake. How can we make the data lake and the data warehouse feature equivalent, I suppose? And that's where Project 𝗫𝐸 comes in. And I think what's cool about Project 𝗫𝐸 is where Project 𝗫𝐸 sort of brings these two technologies to this point of conversions and even beyond it. So before we get into that, I want to talk about some of the reasons that we started thinking about Project 𝗫𝐸 and some of the problems with the data lake that sort of necessitated this journey. And you can think of one of our main problems we have with the data lake is going to be consistency. So by consistency, I mean we have a set of ETL jobs, and these ETL jobs are running. They could be end-of-day jobs, and let's say, for the sake of argument, we have one end-of-day job per region. APAC, EMEA, and North America. The end users can't really see, the data doesn't make sense to the end users until all three of those jobs are finished. And because they're distributed globally and they're doing all kinds of different things, we can't really sync them up very easily. So in the data lake today, how do we typically do this? Well, we use a pointer view or some equivalent construct where this view says select star from table 1, and table 1 is pointing to yesterday's data, or it's select star from yesterday's data where date is equal to yesterday or whatever. So then when all of our ETL jobs have come in and everything's been run and we're fairly confident that things are in a consistent state, we can actually go and by hand move that pointer. So now we're saying select star from today's table, or select star from the table where date is equal to today, or something like that. So you can kind of see a number of problems with this. This is a bit fragile. It's a bit hand managed, and it's hard to do reliably across an entire data lake or data warehouse. There's also the problem of verification. So how do we know that the data is correct? How do we know that all the data has arrived? All these sorts of questions. For that kind of thing, the pointer doesn't really help. The user still has to go in, check out the data, make sure it's okay before they move the pointer. And if it isn't okay and they've moved the pointer, then they have to kind of reconstruct what was there before. Maybe they move the pointer back, but it's usually easiest to just rerun the whole data set, the whole set of ETL jobs. So it's not very scalable for real production use cases. And this concept has a few analogies. And if you're a software developer, you can think of this as a feature for your piece of software. The same sort of thing happens. When I want to develop a feature, I create a branch in my Git repository. I build the feature on that branch, and then of course there's adding unit tests, making sure everything passes, code review, all the other great stuff. And then en masse, atomically, that feature is merged into your main branch. The same thing is happening here. We just don't have a very good hold on how to do it. If you're a database person, you can think of this as a transaction. All of your end of day data comes in, you begin transaction, you insert it into the new tables, and then you commit the transaction. It's the same sort of idea, and all of these ETL jobs land atomically. We just don't have that capability in the data lake. Another issue we have, and I won't spend too long on this one, is the idea of reproducibility. And that one is tied up inside of ML ops and how do we reproduce all of our machine learning models and stuff. Typically, that's quite hard because you have your analysis and queries stored somewhere, you have your data stored somewhere else. Most of the data may not be versioned, or you end up having to create copies of data, and it just gets very sticky. Very hard for you to say, how did I come to this result? I asked a question, I got a result. How did I generate that result? And we want to be able to do this. We want to be able to replay our results in high fidelity and be able to verify those decisions at a later date. So that's kind of where we're at now. I want to stop and start talking about table formats. And by table formats, I mean that's something distinctly different from file formats. We're all fairly used to file formats. On the data lake, file formats are typically things like JSON or ORC or Parquet or whatnot. And these things are really designed to do one thing well. And that one thing is either going to be reading the data, writing the data, modifying single files or single rows efficiently, or human readability in the case of JSON. So these things are optimized to perform on single files. But when you have a larger data set, when you're looking at a data lake, you're going to have hundreds, thousands, millions of these files. So how do you organize those data? And I think most importantly is how do you apply a consistent schema across all that data, so you know that the every column and every row represents the same thing across all the files. And then how do you change those files? How do you update the list of files that is actually valid for your queries? So that's where it gets really hard. A table format is basically saying all of these files, whether they're Parquet or Avro or whatever else, are part of a table. And that's a really powerful abstraction. We stop, the goal here is to stop thinking about files and partitions and folders and all these things that we typically think about as a data engineer, and start thinking about our data lake as a set of tables. And once it's a table, we can bring in all of the other intuition we have acquired from databases around changing these tables, performing optimizations on these tables. You can start thinking about ACID compliance, this sort of stuff. So it's a really, really powerful abstraction, and it's only starting to really take hold in the data lake sort of environment. We've had the sort of the generation zero of this idea of a table format forever, and that's just files in a folder. And that has that's basically not a table format at that point, because you have all the problems of your file formats. How do you know which ones to read? How do you know what the schema is? That sort of stuff. So very quickly, we got Hive and a lot of the Hive sort of compliant processes. And Hive basically says, here's the list of files. Those are the files that you should read for a query. And here's the schema you should apply to that. But it doesn't really do ACID compliance except under certain circumstances. And Hive is also sort of a single point of failure. So you have, you can put Hive behind a load balancer or whatever, but at the end of the day, you have to query Hive for a lot of data, and all that data has to flow over the wire before you can even start your query. So what we've seen now in the past few years is these products like Iceberg, Apache Hoodie, Delta Lake from Databricks come around. And these things are really fulfilling that goal of the table format, where we have a consistent view across the table of which files are in it, what the schema is, and it provides us ACID transactions. So these formats are really cool. They're only table formats. So what we're going to talk about in 𝗏𝐶 first in a second is across a set of tables or a whole database. But speaking on just a table level, we are actually able to start doing ACID compliant transactions and applying consistent schemas and things. So the way a lot of these things work, and I'm going to simplify the way these things work because there are differences, sometimes significant differences in how these different technologies work. But the main drive behind all of these is they actually start storing the metadata with the data on the data lake. So it's starting to treat your metadata as if it's data as well. So when you look on the data lake, you're going to see all of your Parquet files, and then you're going to see a set of metadata files, whether they're in JSON or AVR or whatnot, and that's going to tell you how to read the data files. So in this diagram, we have list 1, and this is our table as it stands today. And you can see this list 1 is, among other things, just a list of Parquet files. It also stores some more metadata, schemas, that sort of stuff. But at the heart of it, it's really saying, to read this table, you need to read these Parquet files. So if I come in and perform a transaction on this table, then we're going to, effectively, we're going to write a new list. And the new list writing is going to be is where we pick up the atomicity. And then you can see the list is just going to contain a different set of Parquet files. So in this case, we're reading 2 of the old Parquet files and 2 of the new Parquet files. And again, we perform another transaction and we get a third list, and it's going to point to, again, another set of Parquet files. So the first thing you notice is we're saving all of these lists. So we're able to do something like what is called time travel or table history. So we're able to move backwards and forwards in time to figure out what our table looked like at different points in time. And that's simply by reading different lists, which represent different times. And then the atomicity that I was talking about really happens when we change what list we're actually pointing to. So right now, our data set is list 3, and that is the most up-to-date view that we have of our table. Now, if I go and write list 4, whatever is pointing to list 3 as the most up-to-date table will have to switch to list 4. And that switch from list 3 to list 4 is where where we get our atomic ACID compliance transactions from. So that we can never read our data table in an incomplete or in a corrupted state. It's always reliable, it's always atomic. So that's our data tables. Iceberg is my personal favorite of these formats, but they all have some strengths and weaknesses. I talk about Iceberg a lot because it's what I understand the best. So now we can move on and start talking about Project 𝗫𝐸. So Project 𝗫𝐸 is really cool. What we're doing here is we're taking these individual Iceberg files or the individual Delta Lake tables, and we're treating them as entire database. And we do that by overlaying a Git-like experience for these tables in the data lake. And by a Git-like experience, what I'm talking about is branches, tags, commits, merges, these sorts of things. They all have analogies, which I'll talk about in a second. But we're not talking about Git-like in the sense of a distributed version control system. You don't check out a 𝗫𝐸 repo. Similarly, a lot of the more advanced features where people can get into a lot of trouble with Git, things like cherry picks or rebases or all the other complex things that Git does, we're not really focusing on here. What we're trying to do is this simple set of operations that allow us to manipulate the data lake as a whole atomically. So Project 𝗫𝐸, as well as being this Git-like experience, it's also built to be cloud native. So there's this service running in the cloud that has all the information about your table metadata. And this thing is, unlike Hive, can be scaled out. It can run as a function like a Lambda function or in Docker or Kubernetes or whatever else. And you can really horizontally scale this. And of course, it's open source. So you're able to, it's Apache license, it's easy to use, it's easy to share. So we're aiming to support all common data tools. Currently, this is limited to Hive tables, Iceberg, Delta, and SQL views. But that'll be expanding over time. And the idea here is that we should be focusing on our modern table formats and modern ways of thinking about data, and try not to think about just files in an S3 bucket somewhere. And we're really targeting integration to all major data tools. So we're going to see Airflow and DBT and all these other really cool tools will be able to interact with 𝗚ESi. And finally, one of the cool things is the idea of these multi-table transactions. So we're able to do the same style of transactions that databases are able to do in terms of this begin transaction, statement commit with isolation levels and all those other good things. And we're able to take it a step further, which I'll show you in a second. Before I get too much further, I want to discuss in more detail what we mean by git-like. So when I say git-like commits, what I mean is a transaction affecting one or more tables is a commit. So that could be updating a single iceberg table, or that could be updating an iceberg table, some views, and a materialized view. But everything is just represented as a commit, regardless of the size of the actual transaction. And then a branch has a strong analogy to what it is in Git. It's basically just an ordered list of commits, and it has a name, a human readable name. So you commit things on the main branch when you read data. If you're not 𝗚ESi aware and you read data out of your data lake, you're just going to read the main branch. So it's sort of hidden behind. You don't really need to understand Git or understand what's happening here. You just get your main branch. But then the more sophisticated users can create branches off of main and then merge them back. And a tag is the same as a branch, but a tag is just pointing to a single commit, and it's sort of an immutable reference that points to your data lake at a particular point in time. And then finally, a merge is again simply analogy to Git, where you're taking everything from one branch and moving it on to the other. So you're able to do changes on one branch, double check them, verify them, test them, and then move them onto your main branch, just as you would for software. One minor difference between Git and 𝗚ESi is that 𝗚ESi doesn't have the idea of merge commits. So you always have this linear history, which is useful in data, but merge commits, I guess, can be important for some people in software, but typically not for data. So we'll take a quick look at what this actually looks like and how we can solve some of these consistency and verification problems. So if you were to look at the data in the data lake at step 1 here, you'd be looking at the main branch. So then analysts and downstream users, data scientists, whoever else, when they're querying the data lake, they're seeing the main branch, and they don't know anything else about the data lake. So when data engineers come along, they're going to create a branch, call it ETL. And just like before, there's going to be a series of ETL jobs that come in. But rather than just writing data into the data lake, they're going to create transactions on iceberg tables inside of 𝗚ESi. So this is going to create commits. So you're going to see in the ETL branch, we're going to build up a series of commits representing the individual ETL jobs. And then at the end of those commits, before we go to step 3 here, you can think of this as being the chance to verify your changes, to make sure everything was done correctly, and make sure all the data showed up. You can do that manually or with a set of tools to verify that this data is good. And then at the end of that, you're basically just going to do a merge. And that merge is going to take all 3 commits from step 2 and promote them into the main branch. And that's going to be done atomically. So this is going to look a lot like a transaction, and you're going to atomically get all of this data moved into your main branch. So then by step 3, any analysts who are querying the data lake and working with the data lake will instantly see all the data that was done on the ETL job without any inconsistencies or without any hiccups in the data. And now this looks a lot like your software use case, where you're creating a feature branch in the ETL here, and you're developing the feature, and you're doing tests and code review and whatnot, and then you're merging it into the main branch. So you can see a real parallel in this with software development. And then that sort of brings me to the idea of these cross-table transactions. So you have the idea, you can do a single system transaction, which is your more common database transaction with start transaction, insert, commit, or rollback. And this is just a single transaction in 𝗚ESi, and you can do that as a single commit. You can also have these really interesting loosely coupled transactions where you're able to create a branch, do some jobs on that branch, different Spark jobs, whatever else, Dremio can create some reflections, that kind of stuff. And then you're able to merge that data back into main. So you're able to really decouple the transaction context from the actual system or tool that's creating the data. And that can be really powerful. So then we can also take a look. I'm actually just going to skip this slide because I think I'm a bit short on time. But the this is solving a reproducibility problem where we're just creating tags in 𝗏𝐶 for specific releases of our data. So that anytime we want to look at training run A, we can go back to the tag that was created called training run A. And data scientists can go and compare that data, compare the ML models that they ran to what actually happened and be able to reproduce their decisions again in high fidelity. So the current status of this project is we have available today a Docker image, or you can run it on AWS Lambda. There's a number of ways you can interact with it. So you can directly interact with the Python client, the CLI, a Java client, or directly from the UI. Then you can also interact from it with it from Iceberg and Delta. The Iceberg integration's a fair bit better than Delta, but we're working with Databricks to get the Delta one as equal to the Iceberg one. You can use it with the Hive Metastore. It's a bit tricky there, but we're working on that one as well. And then we really focused on high performance. You're able to produce hundreds or thousands of commits a second. And finally, we have a variety of storage backends. So this runs, it's best run in the cloud. You can point it at DynamoDB. And we're releasing stuff from MongoDB and a couple of on-prem solutions as well. So you're able to use this in a lot of different scenarios. And as far as future work goes, there's going to be a lot more improvements coming to both Hive, Iceberg, and Delta. We're talking about table management services, and this is the idea of sort of managing the data in your data lake. And this is running automatic compaction jobs, optimizing the data, its layout, its ordering, sorting, creating indices, these sorts of things. And these can all be done so that your database, your data warehouse, your data lake, excuse me, starts to behave more like a database or data warehouse. And then finally, we have a ton more integrations coming. So we'll see a lot more query engines support this, and then a lot of data tools like Airflow and 𝗏𝐻𝑚 and stuff like that. So with that, thanks everyone for joining. We can share out this presentation. It has some links to the demos, to the website, that kind of stuff. It's a relatively new project, and we're actively looking for collaborators, users. It's a small but really friendly group, and we'd love to get people involved. So give me a shout if you have any questions.
Thanks, Ryan, for your presentation. We'll do the question time at the end of both the two presentations. So let me introduce next speakers, Alvin Kjellin and 𝐼 from SODA. Let me say some words. Data comes from even more complex data infrastructure. Across the organization, many different players are now members of the data team. Let me say that it's quite impossible to create data strategies that prevent data issue at all. So comes SODA with the SODA solution, the automatic data monitoring and testing solution. Alvin is a solution engineer and Via is a product leader. The stage is yours. Let us know more about yourself and about your presentation.
Sure. Thanks so much, Maria. Thanks for inviting us. We're grateful to be here, and thanks, Ryan, for a great session on 𝗏𝐶. That was super interesting. So it's going to be me and the project lead for our developer tools, which is Vijay. So he'll be adding some color commentary as we go along here. So really quick, the agenda, I have 2 slides just introducing SODA as a company, and then I'll dig into the platform, kind of how the different pieces fit together. And then I'll run a very short demo and then just some guidance around how to get started. So the company, so our mission statements is essentially that we want to create an observability and collaboration platform in order to resolve, prioritize, and discover silent data issues. This is kind of broad, right? So to dig into it a little bit more, we do that attacking this from a number of different angles. So to start with, we offer automated monitoring in order to make sure that your data is fresh, that it's up to date. We can do time series anomaly detection on specific metrics. So anything around automation and schema evolution as well, to see how schema changes over time. So that's the monitoring part. The second part, which I assume would be the most relevant for this session today, is the data testing. So being able to test your data, including SODA as part of your data pipeline, being invoked from an Airflow or any orchestration engine in order to verify that the data that is produced is of high quality. And we'll get into that as well, but this is primarily the open source part of our offering, and that the target there is primarily data engineers. But we try to address a wider set of users as well. So we talk about data fitness, which means that is the data fit for purpose? Even if it's semantically and syntactically correct, there still might be issues that require some kind of context in order to detect that. So we're trying to enable as well less technical user to set up their rules and collect their metrics that are relevant for them. And the fourth piece here is around collaboration, and that one goes across the previous three. I would say that's all around fitting into an existing ecosystem, and that could mean Airflow that I mentioned earlier, but it could also be being able to create tickets or issues in a separate system so that you can help and collaborate around this, because we believe that building data that's a team sport. So you need to have that aspect of collaboration there. So that's all around kind of what we're aiming to do. And then the platform, really quick. So the different pieces. So if we start from the bottom here, we have the data sources. That could be anything essentially. And then we have two main ways to get to the data. One is that you can connect directly from SODA Cloud, or you can use one of our developer tools here. So the most evolved one would be SODA SQL, which you can connect to your data source in order to collect metrics and then perform tests. And then the results of those tests and those metrics would be uploaded to SODA Cloud, where they can be reviewed and alerted on. And the alerting could be via ticketing, or we provide notifications via email and chat, integrations to data cataloging tools like Collibra and Relation. But we also are working on additional capabilities in the developer tool space. So as I mentioned right now, SODA SQL is the main one, but we are also looking into SODA Spark and SODA Streaming. So Vijay, could you talk a little bit about those initiatives?
Yeah, sure. So as Alvin was mentioning, hello, my name is Vijay. I'm leading the SODA developer tools. So SODA SQL is the developer tool, the open source developer tool that you can use to connect to any of the data sources that speak SQL. And currently we have support for at least 5 different types of data warehouses, from Redshift to Google BigQuery and Snowflake, Athena, Postgres, and there are a couple of experimental ones with Hive and also with SQL Server as well. So any data source that you can connect to and then speak SQL, you can use that one. And the metrics and tests, as Alvin mentioned, will be gathered by the tool itself, and it is very configuration driven compared to the other tools in the market. So you can just install the tool and then make it just create a simple YAML file and then point, okay, these are my tables, these are the metrics I want to calculate. And then it will automatically generate all the metrics that you need. And optionally connecting to the SODA Cloud, you can get all these features that we're highlighting here. And apart from this, because we want to make sure that you should be able to monitor any type of data that you have, any type of data source that you have, we have a couple of more projects under the SODA developer tools umbrella. One is the SODA Kafka thing, which is I think we're calling it SODA streaming. So it connects to right now, it connects to any Kafka stream, and then it can extract the metrics from any of the topics that you have. And it's already in a POC. It's available on GitHub as well. And another one, which is Soda Spark, also known as Soda Data Frame. This enables any of the data sources. For example, if you're able to read any format, any format that you can read using Spark, you can use Soda Spark on top of that one, because this is built to be this is built on top of the data frame. So you can essentially apply the same configuration that you apply on any other data sources, and then extract the metrics for that one. So imagine your data is in one of these data lakes on S3 or Azure Object Storage or whatever, Azure Data Lake Storage or whatever, and then you can just read those Parquet files, create a data frame, and then use Soda Spark, Soda data frame library, and then it will extract all the metrics, and then you can write tests in a much more declarative fashion. That is the main focus for us here, because we don't want data engineers spending a lot of time trying to figure out, okay, how to do the plumbing. So we take that pain out, and then you can use these tools. So all of these tools are open source, so they're available on GitHub. I think we'll give you more information about that one in the later slides. So back to you, Albin.
Thanks, Vijay. That's great. Yeah. Okay. So just to provide a bit more detail around kind of Soda Cloud, that's self-service validation, again, in order to enable a different type of user than the data engineer, so that they can set up their tests as well and configure alerting. And then Soda SQL that we have talked about. So it can be used in two ways. One is via configuring this YAML file, which we'll go over in more detail in the demo later on. But also it can be used as a Python library, and hence being invoked via Airflow as part of your data pipeline. So speaking of that, so this is one example in terms of how Soda can fit into an existing data pipeline. So again, you have some sort of data production here with ingestion. So we can apply Soda directly on that stream. Once it's put in some sort of a staging table, we can do tests before and after transformation to make sure that no records disappear, or if there's any reference data that doesn't get put in there, we could detect those types of things. And then at the last step here, before the data is actually used by someone building a data product or an analyst, you can actually add additional tests that would validate that the data would be fit for purpose in that context. So the idea here is that we collect the data from many different places, and then you get a single pane of glass over all the data quality metrics across everything in your data pipelines. So Soda in action, quick time check, we're pretty good. So I'm gonna switch over to the demo in a second here. I just wanna show you what I'm gonna show you. So we'll start with Soda SQL, how to configure it, how to connect it to a data source, and also to Soda Cloud, how to perform a scan, and then the results of that scan gets uploaded to Soda Cloud, where they can be reviewed. You can add additional tests or customize existing one, and then configure the alert. So that's the basic flow. So starting here, so as I mentioned, it can be used as Python library and as a command line tool. I'm using the command line tool here. It has three basic operations. So the first one is create, and that will essentially set up connectivity to your data source. And the way that it does that is that it generates this YAML file that holds usernames, passwords, ports, that sort of stuff. And as you notice here, the username and passwords are not in clear text in these YAML files. These are externalized to a different property file, so that when you check this into your source control system, you don't add any sensitive data there by mistake. The next step here is analyze. And what happens there is that we'll use these connectivity details in order to connect to the data source, in order to suck intelligence out of it. So what happens is that based on that data source, we will generate one of these YAML file per table or per view that is available there. So if we take a look at one here, for example, like orders. So we auto generate as much as possible to kind of relieve the data engineer of having to configure everything. So we suggest a number of basic metrics like row count, missing count, invalid percentage, min, max, and so on. And then it also generates a number of tests for you. So the most basic one is on a table level here. So looking at the row count being greater than 0, that was probably the most obvious one. But then we also go further. So we look at the different columns, and then we try to detect the different formats of those columns. For example, if we have a product ID here, that's a UUID format that's being detected as part of the analyze phase. But we also go a little bit further once more. So we look at the content of that column and use whatever was there from the beginning as a baseline, so that when we ran analyze, we discovered that, okay, 3% of these are invalid. That will be the baseline for further testing. And then, of course, a data engineer can go on and add additional tests. So like, for example, here, looking at the payment method, you can provide a list of valid values. And if the invalid values goes above 25%, it will alert. And we're trying to provide as many metrics and kind of out of the box tests as possible, but there's always going to be use cases that are so context or customer specific that it wouldn't make sense for us to bake into the product. And kind of the fallback in those cases is SQL metrics. So that's essentially just providing a SQL query, and then you type them as failed rows, for example. So the last step here would be the scan then. So we have this configuration file, and then when we run soda scan, these properties will be translated into highly optimized SQL that you can see here on the right-hand side. And you also see the test results in terms of row counts, the failed orders, and so on. And then at the end of this is getting uploaded into Soda Cloud. But if you're using Soda SQL as a Python library, it's of course possible to extract the results and the metrics and do whatever you want to do with them in Python as well. So that's an option. Vijay, anything you want to add to this?
I think it's maybe a quick thing about the SQL metrics, maybe, because you can also create your own SQL metrics rather than the inbuilt metrics. So yeah, I think you pointed the failed rows. So no.
Okay, cool.
Yeah,
cool. So that's kind of how you work with Soda SQL. So it's really easy to get started with. You just run pip install, and then you're good to go essentially. So I'm going to show you kind of the other piece of the puzzle here, which is Soda Cloud. So you can run Soda SQL essentially anywhere as part of Airflow or standalone or as an AWS Lambda or wherever you want to run it. But then all of these test results gets collected into Soda Cloud. So if we take a look at this landing page, you can see that the different data sets that have been onboarded, you can provide tags and so on in order to help with searchability. You have the row count here, and then we store this in time series database. You can compare how this have evolved over time. And if we go in and look at one example here for orders, for example, we provide some statistics around missing, distinct, and then also generate histograms or frequent value diagrams or what's going on. So if we go in and take a look at this one payment method, for example, where we see that we have 29 invalid one, 4 distinct. And if we expand on this, you also see the frequent values, extreme values, and then also the data monitors that are associated to this specific column. So invalid payment method needs to be less than 25%. That's directly taken from this test case here. So if a data engineer configures that, it will still be available to a less technical user in Soda Cloud in a way that is easier to understand. So if we go in and take a look at this, this is kind of the basic view. Then you can go see the failed rows here that are captured, and then you can search for payment method, for example. And for this one, we can see that, okay, PayPal seems to be the underlying issue here. And we're also going to extend this so that we can look at a failed row and compare that with a successful one, and then generate a suggestion for what the underlying issue might be. And you can also click on certain points in time here, and that will show you the results for that specific scan. So that's a pretty basic example. If we go back here and take a look at another data set around product, And then we want to look at this size attribute here. So some additional statistics around mean maxes, histogram, frequent values, extreme values, and also data monitors again. And here, this is an example of our automatic anomaly detection. So here, there's essentially no configuration at all. So you just pointed to a specific metric, and then based on the historical data, it calculates a boundary. So here, for example, you can see that we get an alert when it's outside of that boundary. But time series anomaly detection is never perfect, right? So at certain points in time, you kind of have to help it along the way and provide feedback, so you help it to learn. And that's why we're providing this type of dialogue where you can say if this was classified correctly or not. And then the last piece here, I want to show you kind of just to get a feel for how an analyst or a data owner could create their own metrics. So if you go in here, you select create monitor, you can select metric or data time arrival or schema events and so on. Let's use a metric now. And here you can generate the filter logic, which essentially generates the kind of the where clause of a SQL statement. So for a specific region or for a specific date range or something like that, that can be configured without writing SQL. And then you select the metric type. So if I want to look here, let's do maximum value for discounts. And then the most basic way to set this up is via threshold. So you can say that, okay, if this is above 99%, for example, then it should raise an alert. Or if it's greater than 90, it should just be a warning. We also can do more dynamic type of evaluations. So you can do a change over time, and then you can compare that to the previous value the same day last week as an average min max over the 7 to 90 days, or as an absolute or a relative. But from a configuration standpoint, the easiest one to configure is the anomaly detection. So then there's essentially nothing that you need to provide. And this part is where you configure the notifications so that if you need to stop data production or if it's an issue in a more like data fitness type of use case, then you can add additional notifications here. So we provide native integration to Slack, for example, or you can add additional team members here as well and set if they would just want to have critical alerts, for example. Then you click next, and then you can see here as well that we auto-generate a natural language description of this monitor, and you can add additional descriptions here as well. So that's it. Maybe one more that I can show you in terms of product data and that dynamic one, just so you've seen what that looks like. So here, this is more that you define your own boundary. This is not based on anomaly detection. So you essentially say if the amount in stock, the average of amount in stock is changing more than 5% up or down, then raise an alert. Great. That was a very short demo. It covers, and it goes fast, but it covers most of the product. So going back to the slides again, how do you get started with SODA? So the best way is probably that you go and create an account on SODA Cloud. The reason for that is that it takes you to a very nice getting started guide, like step by step. It talks you through kind of setting up, onboarding data sets, configuring monitors, and so on. So that's probably the easiest way to get started. But then we provide a lot of support as well to the community, and in order for you to self-serve. So to begin with, our documentation, which I think is really crisp and to the point. It's really easy to understand and get started. And then, of course, we have the GitHub repo where you can add enhancements requests, and then VJ will jump on that directly, typically. And also, if you want to extend it with an additional data source support, that's very clear. We've had a number of these ones being contributed from the community, which is great. And as we mentioned as well, there's additional repos for SODA streaming where that POC part is readily available. And the best way to kind of interact with Soda is via the community, the Slack community. So we have an open community. There's a few different channels there around Soda SQL or Soda streaming. So just get on there. If you and if you run into any issues, then we'll guide you, and you'll see what other of our user base is using. So that went pretty fast. So I think we're slightly ahead of time here. BJ, I'm not sure if you want to add something around the community in addition to what we covered.
Yeah, just to give you some idea of the project or multiple projects. So Soda SQL essentially is written in Python. It's very easy to get into if you find any bugs. Well, as you know, no software never has bugs, but occasionally some things pop up. So you can take a look at it and then hack on it yourself. It's open source, Apache license, so you can just use it right now. And we also have documentation on using it in different settings, as Albin has mentioned, in Airflow and other orchestration services. And the other point is that you don't need to have Soda Cloud account, and the cloud account that we said it's free to register, so you can just register for free. And you can use it optionally if you don't want to use it, or I mean, we would love you to explore all these options that we provide on Soda Cloud, but you can also use Soda SQL without any connection to the cloud. So by default, it doesn't require you to say, hey, go and make an account with us first. Yeah, I think that's pretty much it. So we'd love if you can check out the source code, give the tool a try, and also say hi on our Slack. I'll be happy to get any feedback from you.
Perfect. Thanks so much.
Thank you, Albin and Vi. Thank you for your great presentation and for being with us today. And now let's start the Q&A session with the first question in chat, the first public question. We have more in private way. This is for Ryan, Project 𝗏𝐿. For those, just a moment. Okay. This is all possible because is a change data capture architecture, history of insert, delete, update the data, and leverage this metadata to know the branches of data.
Yeah, sort of. It's not explicitly using any CDC, but it's saying every time you do an 𝗏𝐿sberg transaction, you write some metadata out, or a delta transaction or whatever else. So what you're doing is you're storing the history of all the relevant metadata files. So you can always move between those, and you can merge those those metadata files back together and that kind of stuff. It's not explicitly CDC, but it has a lot of the flavor of CDC.
Thanks. I know that Stefano has some more questions for you.
Yes, I have a couple of questions. One is for Ryan, and the other one is for all of our speakers all together. Ryan, I really like Project 𝗏𝐿, and I'm figuring out the benefits of 𝗏𝐿 in a lot of use cases. For example, for machine learning, where I can test with different branches. I can create data set and manage these data sets in a very easy and efficient way. But what do you think about using, or what kind of benefits I can have with 𝗏𝐿 and maybe with 𝗏𝐻𝑒𝑟g in time series data sets? Do you think it could be useful even in this use case?
Yeah, I'm trying to bring back some of my time series experience. I did a lot of that in a previous life. I think 𝗏𝐿 would work quite well with time series. I don't think there's anything preventing it from using time series. I think one I've seen difficult with time series is very frequent updates. So if you're streaming some data out of Kafka or something like that. And Iceberg doesn't love high frequency transactions. So you should probably look at a couple of minutes per transaction with Iceberg. So I think with time series, that's where you get in trouble. Time series is, in that case, you're also going to have the small file problem. So each transaction is going to only have a few dozen rows. So then you really need your compaction jobs and the table management stuff I spoke of to make sure that the data is optimized for read later.
Okay, so not so much benefits. Yeah, we need extra jobs, extra work. Okay, thank you.
Yeah, you always have to make sure the data is clean. Yeah.
And the other question is for all of you, because I'm trying to, I'm imagining something like that, and please tell me if I'm wrong. I have a T-shirt for Kafka Summit, and because we use a lot Kafka to collect, to ingest data into a data lake, into Parquet, and maybe in future into Iceberg. And I'm thinking about it could be useful to have Soda Kafka to check against the data in motion through Kafka, then store it in the data lake, and to have 𝗫𝐸, of course, on top to have all the benefits of 𝗫𝐸. And then I can even check the quality of the data through Soda Spark on top of 𝗫𝐸, to have the control across all the pipeline and all the processes. Is it right? Is it feasible in the future? What do you think about?
I think from my perspective, I've already joined the Soda Slack channel, because in some ways, for me, the branching mechanism was actually, some of the benefits is actually exactly what Soda does. So you can sort of do where GitHub has actions and you can do checks before you can merge a pull request. There's some really cool things where you have a branch, you've done some commits, and then Soda makes sure, or something like that, make sure that the data is good and data is high quality before it actually lands in the data lake or the database. I think that really excites me, and that's why I've already joined your Slack channel.
That's super cool. I think I didn't know that you're on the Slack channel, so I think I should poke you more, because I really love the presentation about Apache Arrow. I think that's the one that made me understand Arrow properly on YouTube. So thanks a lot for that. So I didn't know if you're on that one, then I would have fanboyed more on the channel. Because we have around 200 people already. I think 220 something people on Soda community channel. So it's now getting as I say, it's becoming like bigger than Dunbar number from me to know who is there. Anyway, for your question, Stefano, I think that it's certainly possible, because that's what we are striving in the open source world, right? To make sure that the tools that we're building are compatible with each other and as much as possible. So that's why we are trying to take the standardized way of talking to different data sources. The reason why we picked SQL, because obviously SQL is back. Pretty much everywhere you see SQL, not just the query engines, but also, not just the storage way, but also the query as well. That's what you see with KSQL and Materialize and all these people, because you have the knowledge of declarative query language. Why not use it, and don't lose it. So for us, that is the main reason why we started with SQL. And just now I just created a branch called Spark SQL dialect, so you can also talk to Spark clusters with Hive Metastore using Soda Spark. And coming to the streaming, yes, I mean all these tools, all the open source tools have this really nice interface and good, well documented things, and that's where we want to plug into. So it certainly makes sense to utilize. And as Ryan was mentioning, that there is a bit of an overlap between different tools, and there is also something that we think we are doing a bit different than other data quality tools. Obviously, we believe that's slightly better. Otherwise, we wouldn't do this. So it's a bit of a bias there. But yeah, I think the architecture that you're drawing makes sense to me, actually. So I think we can talk more about it, and then specifics, I think, contextual level. I don't know much about 𝗏𝐶. I'm just learning it from the talk by Ryan right now, so I might not be the right person to say, yes, you can connect to 𝗏𝐶 and do everything.
We will try it. And I totally agree with you about SQL. One of my speech a couple of years ago, the title was "The SQL Revenge Against NoSQL," and of course now it's back. Yes, I agree.
Nice.
Thank you.
Okay, so we have time for some more questions. Once more for the Soda guys. Will Soda SQL work without Soda Cloud?
Yeah, I think that's what I just mentioned as well. As I said, cloud is an optional component. When you install Soda SQL, any of the warehouses, there is no mandatory requirement that you have to create a Soda Cloud account. So you can just use it without any knowledge of Soda Cloud. The very moment you want to use Soda Cloud, you can just create an account, get the API key, and then just configure it in the warehouse, and then everything works automatically. So you don't need to do anything extra to connect to Soda Cloud apart from providing the API key and then a secret in the configuration. So it is standalone tool, open source tool. It has nothing to. It's not tightly coupled to Soda Cloud to get started to use it.
Okay, thank you. Now once more for Ryan about Project 𝗏𝐶. You talked a little bit about the different types of transaction. Could you say a bit more and where they might be useful?
Yeah, I think in the slides, I probably too briefly talked about it. The idea that there's these two types of transactions. There's the database transaction that we're all familiar with, where you do begin transaction, commit, 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 or select, 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 commit. You can do that in 𝗏𝐶, and that's fine, but it's sort of, you have to localize that to one application. So that's one Spark job, or that's one JDBC connection or something like that. So that brings us sort of to parity with the data warehouse, which is cool. But I really like the idea of these, what I called loosely coupled transactions in the talk. So there we can think of something like running an entire Airflow DAG, or even a set of Airflow DAGs. And those might have various jobs in Python or Spark or wherever else. And those are all going to commit on the same branch. So they're all going to be part of the same commit context. So now you're sharing this transaction between a number of different projects. And then at commit time, you're sort of making your entire, say, Airflow DAG will be an atomic transaction, because that was all done on one branch, so that all gets merged at the same time. So I think that gives some power that you can't really get in a data warehouse. And I think that in certain contexts can be super useful, especially when you are changing two tables and then creating a materialized view of the join of those two tables. You never have to worry about those data sets being out of sync.
Okay. And one for all of you, an open question. Considering your point of view of the data management ecosystem, which are the biggest challenges to deal with nowadays, and how the ecosystem is going to change in the next 5 years?
So, guys, you want to take that one first?
That's your name on it, Vijay.
I mean, we all know, future predictions are, perfectly plausible, and it's pretty easy to say exactly what is going to happen in the next 5 years. So I think I can talk about the current ones, because based on my experience so far in the running data teams and running teams of analysts and then data engineers together in some fintech and other e-commerce companies. So one of the big challenges is so I see the industry transitioning from, first there was like, we identified that there is a lot of data, let's get the stuff in. So most of the projects were focusing on industries trying to solve how to get the data in one place to the other place and make it more usable. And then now the biggest question is, okay, we got all the data now. Is it really worth, to use it? Is it really valuable? Is it really valid? So that is the main challenge that I think that we have, because we started collecting, I think sometimes even going over the board, like collecting all sorts of crap that you're not supposed to collect, I think, as we know. But now there is this question of the data that I collected, is it valuable for business users? Is it valuable for predicting anything? Is it valuable for usage in machine learning? What is the data quality? And so this is what I think that the current challenge is, and that's what that's what we are trying to solve in our own way to provide the visibility into that one. And yeah, I think the next 5 years, I don't know. That's a magical thing. And one thing, the trend that I'm noticing more and more is that all the best practices from the software engineering, and there is this kind of a line between software engineering and data engineering, and slowly we are trying to consolidate them together, trying to see which ones are the best practices that we can bring into the data side as well. There is kind of a glass boundary between data engineering and software engineering. So I'll see more and more, as Ryan pointed out as well, the kind of branching, and then this thing kind of an established best practice when you're developing code. And it's the same thing from our point of view. Testing your software is a best practice, and we are trying to bring that to data. So I think more and more these kind of things happen, in my opinion. And yeah, I think real-time data streaming, that's going to be there. As you probably have seen, Confluent is now on NASDAQ. So I think a few hours ago, I don't know. So streaming is going to be everywhere. That's my future prediction. So I'll let Ryan tell his opinion. I think that's much more valuable than my ranting.
I fully agree, actually, in terms of the software and the DBA sort of convergence. I think the DBA has always been a bit of a dark horse in your software organization. They're always a little bit different. They're always a little bit hard to understand. They always have a little bit different way of doing things. And software has taken a number of shots at them. I think we had ORMs, and then we had MongoDB and all the NoSQL databases and stuff, but it could never really bring down our big DBAs, relational guys. And I think this new turn that we're seeing, where we're seeing a lot more data observability, data best practices, unit testing your data, all these sorts of things. I hope that's finally going to make these two different communities of engineers finally talk the same language. And I think it's probably the most important problem right now, because I don't think we really understand our data, and it's one of the most valuable resources that company has. Aside from that, I think the future, I'm starting to see a lot more sort of hybrid computing in the industry. And what I mean by that is, we've seen GPUs, they've been around for 5-10 years now, but we're seeing a lot more of those and a lot of real applications being done on GPUs. A lot of cloud people are starting to introduce ARM CPUs and ARM services and stuff. A lot more work with ASICs and FPGAs and things. And I think we're going to start seeing a lot of tuned hardware for the applications, something that's just really good as a SQL, as a general purpose SQL database, or something that's really good at machine learning. We have Google's TPUs and stuff. I think we'll see more of that in the future, if I had to make a guess.
Thank you for your predictive point of view. We'll meet in 5 years to talk about this.
I have a question. Do you have some Confluent shares? Are you going to be rich? No. Okay.
No. I hope they're going to stream it to the public. Now it is an IPO, so we can connect to that topic and then buy some shares. Read that it's a 28% up or something on day one. So.
Yeah.
last minutes. We have no more questions. I want to thank you again because it is a great honor having you three in the same meetup this evening for the community. This is a recorded meetup. I know that there will be a lot of views in the next day, and maybe we'll get in touch for a further appointment in the future. Okay, so many thanks for being with us this evening.
Thanks for having me.
Next time you are welcome in
Thank you.
Italy. We will host you in Italy.
All
Oh,
right.
yes.
Yes, we're looking forward to it.
Done.
With a live meetup. Huh?
Yes.
In the nice Italy.
Thank you.
Definitely.
Thank
Bye-bye.
you.
Have a
Thanks
nice
so much.
evening.
Take care.
Bye-bye.
Bye-bye.
Bye-bye.